In 2024, the United States Air Force publicly reaffirmed a plan that has quietly shaped its future for more than a decade. A bomber fleet capped at roughly 100 B-21 Raiders. At the same time, it outlined a next-generation fighter force of around 185 aircraft in its most advanced category. On paper, these numbers describe the most sophisticated air arm ever assembled. Stealthier, longer-ranged, more networked than anything that has flown before. Yet according to analysis from institutions like the Mitchell Institute, they also describe a force that could struggle to sustain combat against a peer adversary over time. The irony is subtle but revealing. The limiting factor is no longer speed, stealth, or sensor fusion. It is arithmetic. How many aircraft exist, how fast they can be built, and how much each weapon costs once the shooting starts. Most people assume American air power is constrained primarily by politics or strategic restraint. The popular mental model is that the United States chooses not to build more, not that it cannot. It has the technology, it has the industrial base, it has the budgetary capacity. If a major war erupted, the assumption goes, production lines would surge, arsenals would refill, and output would scale as it did during the Second World War or the early Cold War. This belief feels intuitive because it is anchored in historical memory. Images of aircraft factories running around the clock, of tens of thousands of planes rolling off assembly lines, of defense budgets consuming vast portions of national output. Compared to those eras, today's force looks small by preference, not by constraint. But that intuition quietly misses how the system now functions. Modern air power is not a reserve that can be expanded quickly through political will alone. It is an ecosystem shaped by long acquisition cycles, narrow supplier bases, highly specialized labor, and munitions whose cost and complexity resist rapid scaling. The question is no longer whether the United States can strike first. It is whether it can keep striking week after week, month after month, against an adversary that is prepared to absorb losses, trade space for time, and pressure production timelines. To see this clearly, it helps to anchor abstraction in a physical place. In Palmdale, California, inside Northrop Grumman's Air Force Plant 42, engineers and technicians assemble the B-21 Raider. The aircraft is designed for endurance. Its stealth coatings are meant to be maintainable over decades rather than requiring the fragile upkeep of earlier generations. Its avionics architecture is modular, designed to accept upgrades without redesigning the airframe. Its entire philosophy reflects longevity. Everything about it signals patience and persistence, except the pace at which it can be produced. Public reporting and analysis cited by defense observers show that the B-21 program is structured around low-rate, carefully controlled production. This is not a temporary phase, it is the model. That model is the product of decades of acquisition reform. After repeated cost overruns, delays, and cancellations in the late Cold War and post-Cold War era, the Pentagon redesigned how it buys aircraft. Programs were made more conservative. Risk was pushed earlier into development. Production ramps were flattened to avoid surprises. These changes improved reliability. They also hardened constraints. Once a program is designed for steady, predictable output, it becomes extremely difficult to accelerate without breaking the very safeguards meant to control cost and quality. This is how accumulation begins. After the Cold War, the United States steadily reduced the size of its bomber force. The B-52 fleet declined. The B-1 fleet aged and faced availability issues. The B-2 production line closed after just 21 aircraft. Each decision made sense in isolation. Budgets tightened. The Soviet Union collapsed. Precision weapons promised greater effect with fewer platforms. Air power appeared to be entering an era where quality could substitute for quantity. Over time, these rational decisions accumulated into a force that depended on a small number of exceptionally capable assets. Each bomber became more valuable, and each loss, maintenance delay, or production slip carried disproportionate strategic weight. Entrenchment followed naturally. Production lines that shrink do not easily expand. Skilled labor migrates or retires. Suppliers consolidate or exit the market entirely. Tooling is optimized for current output, not hypothetical surges. According to studies by RAND and long-standing analysis from the Congressional Budget Office, Restarting or significantly expanding production of complex military aircraft can take many years even when funding is available. The constraint is not only money, it is time, certification, workforce training, and supply chain reconstruction. The system becomes a narrow pipeline. It flows smoothly, but only at a fixed rate. Leverage emerges from this rigidity. A peer adversary does not need to match American technology aircraft for aircraft. It needs to understand where the bottlenecks lie. If a bomber takes years to replace, then its value extends beyond the mission it flies. It becomes a node in a network where time itself is the scarce resource. The same logic applies to fighters. The Air Force's future fighter concepts emphasize fewer manned aircraft with broader roles, supported by unmanned systems. Budget documents and analytical commentary suggest this architecture prioritizes survivability and adaptability, but it also concentrates capability into a smaller number of airframes. Attrition, once absorbed through numbers, now reverberates through timelines. Munitions deepen the constraint further. Modern long-range weapons are astonishingly effective. They allow aircraft to strike from outside defended airspace, to destroy targets with precision unimaginable a generation ago. They are also extraordinarily expensive. Hypersonic glide vehicles, long-range cruise missiles, and advanced air-to-air weapons can cost millions of dollars per unit, as documented by the Government Accountability Office and reported in defense coverage. Production rates are limited by specialized components, test infrastructure, and safety regulations. Even with emergency funding, output cannot be doubled overnight. In a sustained conflict, the stockpile becomes not just an arsenal, but a ledger. Each strike draws down a balance that cannot be replenished on wartime timelines. The metaphor here is not a sword waiting to be swung harder, but a circulatory system. Aircraft are the arteries, munitions are the oxygen, production lines are the heart. Under normal conditions, the system functions beautifully. Flows are predictable, maintenance cycles are optimized, costs are controlled. But when demand spikes beyond design parameters, performance degrades, not through collapse, but through constraint. The heart can only pump so fast. History offers quieter parallels. During the Cold War, both the United States and the Soviet Union fielded massive armored and air forces. Over time, those forces became smaller and more technologically sophisticated. When conflicts stretched longer than anticipated, logistics and production capacity often proved decisive. In Vietnam, in Afghanistan, in smaller proxy conflicts, the challenge was not initiating combat but sustaining it. In the commercial world, semiconductor manufacturing illustrates the same principle. Advanced fabrication plants require years and tens of billions of dollars to build. Demand can spike overnight. Capacity cannot. Once fixed, leverage accrues to those who understand the choke points. Across allied countries, the pattern repeats. Japan's post-war defense industry prioritized quality and efficiency over scale, producing highly capable systems in limited numbers. European air forces followed similar paths, relying on multinational programs that optimized cost-sharing but constrained surge capacity. The United States is not an exception. It is part of a broader structural shift toward capital-intensive, low-volume military production. What makes the American case distinct is not the presence of constraint, but the assumption that constraint does not apply. The consequences unfold quietly. Strategy adapts to inventory. Doctrine emphasizes precision, selectivity, and escalation management. Campaigns are designed around limited numbers of high-value sorties rather than sustained mass. Think tank analysis from institutions like Brookings and the Council on Foreign Relations suggests this shapes policy long before crises erupt. Options that require prolonged air pressure become harder to contemplate, not because they lack merit, but because the system would strain under their demands. Changing this architecture is possible, but slow. Doubling bomber procurement, as some analysts advocate, would require not only funding, but decades of commitment. Estimates suggest such an expansion could cost well over $100 billion, and that figure excludes parallel investments in munitions plants, training pipelines, basing infrastructure, and maintenance capacity. Each of those elements has its own inertia. Each is governed by regulations, contracts, and labor markets designed to prevent rapid change. There is a strategic irony here. The pursuit of efficiency, predictability, and risk reduction has produced a force that is extraordinarily reliable in peacetime and tightly constrained in prolonged war. The system discourages waste, it minimizes surprises, it also limits elasticity. This is not a failure of planning. It is the natural outcome of institutions optimized for control rather than expansion. As the timeline stretches forward, the questions remain unresolved. Can production be made more elastic without reintroducing the cost overruns and failures of the past? Can munitions be designed with scale and affordability as core attributes rather than secondary considerations? Or does the architecture itself impose a ceiling that strategy must accept and work around? Analysts at RAND and commentators in the Financial Times suggest these questions sit at the intersection of economics, engineering, and organizational behavior. They do not yield to quick fixes. The story of US air power today is therefore not one of decline or dominance. It is a story of structure, of how numbers, timelines, and costs quietly define what is possible long before a crisis demands action. The bombers assembled in Palmdale, the fighters still on drawing boards, the missiles stored in bunkers, all exist within a system that rewards patience and penalizes haste. Whether that system can adapt to sustained pressure remains an open question, one that does not announce itself with dramatic failure, but one that will continue to shape choices, trade-offs, and constraints long after public attention moves on.